Hi my friends, welcome to my channel. Today we will discuss the physiological anatomy of skeletal muscle. In the shortest time possible,
Welcome to Mark MD, where we tackle medical and
approximately 40% of the body is skeletal muscle, and maybe another 10% is smooth and cardiac muscle. In the figure, it is shown that skeletal muscles are composed of numerous fibers that vary from 10 to 80 micrometers in diameter. Each of these fibers is made up of successively smaller subunits. Now, in each muscle fiber you find the sarcolemma, which is a thin membrane that encloses a skeletal muscle fiber. The sarcolemma consists of a true cell membrane called the plasma membrane and an outer layer formed by a thin layer of polysaccharide material that contains numerous thin collagen fibrils. At each end of the muscle fiber, this superficial layer of the sarcolemma fuses with a tendon fiber. The tendon fibers, in turn, join together in bundles to form the muscle tendons that then connect the muscles to the bones. Well, the myofibrils are composed of actin and myosin filaments. Each muscle fiber contains several hundred to several thousand myofibrils, which are illustrated in the video image. Each myofibril is composed of around 1,500 adjacent myosin filaments and approximately 3,000 actin filaments. So if they ask you what actin and myosin are, your answer will be, they are large, polymerized protein molecules responsible for muscle contraction. The large cylinder represents a complete muscle fiber. Inside you see light and dark stripes because it is filled with aligned myofibrils. The labels indicate Z disc, the dark line that marks the boundary of the sarcomere. I band, the light zone, only actin. A band, dark zone, actin plus myosin. H zone, the central part of the A band where only myosin is present. M line, the exact center of the sarcomere. All of this together forms the famous striated appearance. Now pay close attention. This part is key. A sarcomere is enlarged here, which is the contractile unit, located between two Z discs. Inside you see thin filaments, actin, extend from the Z disc toward the center. Thick filaments, myosin, located in the center. H zone, the part of the myosin that is not overlapped by actin. Interdigitation, overlapping, where actin and myosin mix so they can contract. In this black box, you can see the heads of the myosin cross bridges. Tail of the myosin, the straight region. Hinge, flexible part. Head, where the cross bridges are located. These heads are the ones that pull the actin to produce contraction. What does all this mean? 1. The myosin heads, cross bridges, are the ones that attach to actin. 2. From the Z disc, the actin filaments extend toward the center. 3. Actin mixes with myosin, interdigitation. 4. The Z disc passes through all the myofibrils. That's why you see stripes, striations. 5. The entire muscle fiber appears striated because of this perfect alignment. Explained quickly in this video.